Hey there class, so I'm just going to go over this lesson 3, simplifying rational expressions. You do have homework for this one. It's just that same worksheet that I handed out earlier. It's a handout, sections 1.5 is what you're going to be covering. Numbers 1, G and H, 3 to 6, R, H, C. That means that for numbers 3 to 6, you're only doing R, H, and C. 8 and 16, A, B, C. I was just clarifying that the arrow just means that you're only doing R, H, and C for that one. Starting off with our learning goals, by the end of this lesson, you will be able to simplify rational expressions to their most simple term and also straight restrictions for those variables, as well as factor rational expressions and straight restrictions as needed. Those are your 2 learning objectives for this lesson. A little bit of recall from maybe grade 9. Rational numbers or rational are expressions are those that are it's like fractions, right? So it's a over b, where a and b are integers. So you have 1/2, you have 2/3. You can't have 2.5 as a or b. That doesn't count. And you can't have b is equal to 0. And the reason that you can't have b is equal to 0 is because you can't have a 0 in the denominator. That automatically makes this undefined. Okay. So a few examples of, rational expressions. So you know what rational numbers are, where you have 1/2, 2/3, all that kind of stuff, fractions. Rational expressions are basically just rational terms. So it's basically division of polynomials, right? So you have, instead of 2 over 3, you can have something like 2 over x. You can have x squared minus 4x plus 4 divided by x squared minus 4. So basically now rational expressions are where you're dividing polynomials. Okay, so you've probably seen these before. This isn't anything new for you, but what you haven't seen before is restrictions. Since division by 0 is undefined, there are certain restrictions as to what the variable cannot be. So basically what the variable can't be is something that'll make the bottom of this rational expression or any of these equal to 0, right? And in order to find that, we need to find what the zeros of that particular polynomial are. Sometimes it's easier than others. So like something like 2 over x, super easy. You know that x can't be 0, but it can be any other number. With x plus 3, you'd have to do a little bit more work. If you're given something like x squared minus 4, you'd actually have to factor it, and then, you know, using the zero sum property that we learned when we were doing solve by factoring, you'd actually have to determine what that would be, what the 2 numbers that will give you a 0 on the bottom would be, and that would be your restrictions. Okay, so I know that sounds very complicated, but once we go through it, it'll be very, very easy. So let's just go and do a few examples as to how to find restrictions. So the first example says, what restrictions must be placed for on the variable for each of the following. So 2x is pretty easy. We know that the denominator itself, this denominator, cannot equal 0 because you can't divide by 0. Right? So I can say x cannot equal 0. It can be 1, it can be 2, it can be -1, -3, it just can't be 0. So that one's pretty easy. Moving on to something a little bit more complicated, we know now that this can't equal 0, so I'm going to write that out as an equation. So I know x plus 3 cannot equal 0. So if I want to find out what x itself can't equal, I just need to solve it and find what x is, right? So I'm going to go find, I'm going to move this 3 over to the other side by subtracting it on both sides. Now I'm left with x cannot equal -3, right? And it's just basically, you're just solving, but now instead of an equal sign, you have a cannot equal sign. So in this situation, if I was to ask you what the restrictions that are placed on this variable are, the restrictions on this variable are x cannot equal 0. Okay? So that, I hope, makes kind of a lot of sense. We're going to do a few more complicated problems. Obviously, we start off with the easy ones. We make them progressively harder. So let's do this one together. So we have 2x minus 3, x in bracket 2x plus 1. So we know that that bottom term cannot equal 0. So we're going to have to figure out, okay, we have this bracket, right? We're going to say, okay, here we know that x cannot equal 0, because if x was 0 here, automatically 0 times anything will give you 0. And then we know that this bracket itself cannot equal 0. So we're going to say 2x plus 1. I'm actually going to take the bracket off because I don't care for it. And then cannot equal 0. So now I want to isolate for the x. I want to find out what the x would be and what it can't equal. So 2x plus 1, I'm going to minus 1 on both sides, cannot equal 0, minus 1 on this side as well, right? So then I'm left with 2x plus 1 minus 1 cannot equal 0. I want to get rid, 0 minus 1 is just negative 1, sorry. Negative 1, and now I want to get rid of the 2 here, so I'm going to get rid of the 2 on this side. X is equal to negative 1 over 2. So now I know, therefore, the restrictions for this particular denominator are such that x cannot equal negative 1 over 2, or x cannot equal 0, because if x is any of those, the bottom will equal 0. Right? Therefore, x cannot equal negative 1 over 2 or 0. Okay? So I want you to try this one on your own. This one's a little bit more complicated because now there's two, there's two variables, but it's still the same. You still need to solve for what x cannot equal. It's just now you can have x cannot equal something y. Okay? So try that on your own. Pause the video and then I'll take it up with you. All right, hopefully you pause the video and we're just going to take this up together. So we have 5x here over x minus 3. I don't really care for the 5x. It's not important for me right now. We're just going to go over the x minus 3. 3y. X minus 3y. We know that entire term cannot equal 0. So the x just seems to be the easiest and most logical conclusion to go and solve right now. I'm going to subtract 3y on both sides, minus 3y on both sides. So I'm left with x cannot equal 0 minus 3y is just minus 3y. So my first answer is x cannot equal minus 3y. Right? But x isn't the only variable there. Y is 2. So while we solved it in terms of x, we also need to solve in terms of y and find out what y cannot equal. Right? So I'm going to do the same thing here. I'm going to say, okay, x minus 3y. Oh, sorry, this should be plus 3y. I'm sorry, because it was minus 3y. So plus 3y. So x cannot equal 3y, right? Equals 0. So let's go ahead to the 0. So then I'm going to move the 3y to the other side. So I'm going to say x cannot equal 3y. And I want to get the y by itself now. So I'm actually going to divide both sides by 3, right? So now we know that y cannot equal, I'm just rewriting this, y cannot equal x over 3. And that's the answer. So therefore the restrictions here are, therefore the restrictions are, x cannot equal 3y, and y cannot equal x over 3. And that's the answer. So there is like methods and steps to solving rational expressions. I've kind of just gone ahead and wrote out these steps for you. The first thing is to always factor fully the denominator and the numerator, right? Just go ahead, factor both sides. Then state any restrictions. If there is dividing or simplifying or any of that stuff that you need to do, you need to cross things out, go ahead and do that. And then include the restrictions in your final statement. Okay? So again, factor fully both the numerator and the denominator, then state any restrictions in the denominator, then divide out, simplify, if you can cross things out, all of that stuff, right? And then write your final statement with your restrictions in it. So we'll do the first one together, and then I'm actually going to have you pause this video, work through F and G by yourself. They eventually just get more and more complex. So what I'm going to have you do is at each one, pause, try doing it by yourself, or even try at this point to do all of them by yourself. Maybe watch me do E first, and then try to do F and G by yourself, and then I will do A from example 3, and then you can try and do B and C by yourself. B and C are pretty complicated, so I will go through how to do one of these more complicated ones, but they're designed to be complicated. They're designed to test your thinking. Okay? Alrighty, let's get started with this one. This one's pretty straightforward. The first thing you need to do is, and I'm going to go ahead and write these steps out for you. One, the first step is to factor fully both the numerator and the denominator. So let's go ahead and do that. Now, I'm actually just going to move this step up here so that we have a little bit more space to work with. Okay. So let's go ahead and factor fully the numerator and the denominator. So if I look at these, I know that I can pull out the greatest common factor from the top. So the numerator is 15x squared and the bottom is 6x squared, and I know I can pull out from both of them 3x. So I'm left with 5x at the top, and then if I pull out 3x from the bottom, 6x turns into 2y, sorry. Right? Now I want to make sure that I state my restrictions. So the second thing I need to do is, before I even start crossing stuff out, got to make sure I state my restrictions. So let's go ahead and state the restrictions here. If I go and look at this, 3x cannot equal 0, right? And the 2y cannot equal 0. So let's go ahead and solve that. 3 divided by 3, x cannot equal 0, right? And then 2y cannot equal 0. So let's divide that by 2, divide that by 2. Y can also not equal 0. Those are my restrictions. And I'm just going to highlight them because I need them later when I write my statement. And then what I'm going to do is I'm just going to go ahead and cross out from my original statement. So it just says divide out and simplify. Right, so I'm just going to go ahead, divide it out and simplify. So I'm left with 3. Sorry, I'm just going to do this in the blue pen to keep it consistent. So I was left with 3x, 5x divided by 3x. I'm sorry, it's getting a little bit tight down here. 2y, right? Cancel those 2 out, so I'm left with, and I'm just going to write that in my statement. So then for state with restrictions, so I'm left with 5, and again I'm just going to write it for the interest of clarity with this pen. 5x divided by 2y. That's my most simplified expression. The restrictions are x cannot equal 0 and y cannot equal 0. Right? And that is my answer. So that's when you're doing one of these types of problems, that's how you're going to try to answer them. Okay? So try and do F on your own, and maybe even try to do G on your own. With G, you do need to factor the top as well as the bottom. The top might be a little bit complicated, but remember that you can factor out negative ones. So I will go over that, but try doing both F and G on your own. So pause the video here, and then when you're done, we will take it up together. Okay, so hopefully you pause the video. Let's go through this step by step. I won't write out the steps this time. I'll just write out maybe the number, and we'll just go through it. So step 1 is always to go factor fully. So let's factor our bottom here. We know that we can pull out from this bottom here, the greatest common factor is going to be 3x, right? And this is why factoring is so important and why we went over and we learned it. So 3x is what we're factoring out here. That leaves me with x minus 5, right? So let's go over that. We're left with x minus 5. We're going to split this up so that we can solve what this would be like if it was 0. So 3x cannot equal 0, right? And we're left with x minus 5 cannot equal 0. I'm just going to divide both sides by 3. X cannot equal 0. x minus 5 plus 5. So 0 plus 5 is just 5. So x cannot be 5 and x cannot be 0. And I'm going to change the color of this pen because sometimes I feel like sometimes it's hard to see. So I'll change it to pink. And that's what I did. So now that I'm done stating my restrictions, so I factored fully, I went ahead, I changed my restrictions, and then I'm going to go in and I'm going to say, okay, let's just start canceling stuff out now, right? The only thing I can really cancel out here, I'm just going to rewrite it too, just so that we can see what we're working with. So I'm going to rewrite it out. You don't always have to rewrite it out. If you can just go ahead and work with the number at the top, that's fine too. I'm just doing it for the sake of clarity. You can cancel these two x's out. These are dividing. You can't cancel the x in here because it's in the bracket. And there's a subtraction sign in front of it. You cannot do that. It's like illegal in math. So then I'm left with 1, 3x minus 5, right? And the reason that you need to do the restrictions before you start crossing stuff out is because of this, because now the x is gone. So if you had done them after, right, you wouldn't have gotten the right restrictions. And then last but not least, you want to, I'm just going to use that same one. You want to make your statement, so you want to write your restrictions. X cannot equal 0 or 5. And I like to just highlight my final answer like that. Okay? So I'm going to go ahead and do this one now. So let's go here, starting with number 1, right? We have 2x minus 3. So let's go ahead and just factor this fully. So I'm actually going to factor the bottom one first because I find that easier to factor. So it's 2x minus 4. I know that 6 and 4 both go into 2, or 2 goes into that number, so I'm just going to pull out the 2. I can't really put on an x, so I'm just going to do, I'm left with 3x minus 2, right? And notice how up here it's 2 minus 3x. So it's like those two signs are just switched. What I can do is I can actually pull out from up here to make it look like 3x minus 2 so that we can cross stuff out. What I can actually do is I can actually pull out the negative 1. So if I pull out the negative 1 and I divide everything in there by negative 1, I get negative 2 plus 3x, which is basically, if you go and you rewrite it, 3x minus 2. It's the same thing, right? If you just divide it by negative 1. Okay, so then what I'm going to do is I'm going to say, okay, now I want to go ahead and state my restrictions. So let's do that. 2 doesn't really have a variable in front of it, so I really only care about, or with it, sorry, I only care about the 3x minus 2. That cannot equal 0, right? And if I do that, I'm going to take 3x cannot equal 2 divided by 3 divided by 3. So I know x cannot equal 2 over 3. So that's my restriction. I only have one restriction here. Okay, then I'm going to go in, I'm going to say, okay, now I want to go ahead and just cancel everything out. So I'm going to go ahead and I'm going to rewrite, and I'm not going to rewrite it, I'm just going to show you how I do it here. So in this situation, I can actually cancel out these two brackets. So I'm left with a final statement of, the simplified version of this is 1 over 2, x cannot equal 2 over 3. And the reason that I really did need to go ahead and do the simplification and the restrictions first is because if I didn't do that, then I would not have the right restrictions, right? Because there's no variables here. So that's really important that you make sure you put your restrictions as soon as you factor the first time. Okay, so I'm going to have you pause and go through these again on your own. Maybe you can watch me go through the first one. This one is a little bit harder. You do need to go through, factor the numerator, factor the denominator. I often do these separately. I think because they're polynomials, I don't like to do them all in one step. It just makes it very messy for me. So I actually break it down the first step into 2 steps. I factor the numerator, then I factor the denominator, Then I go ahead and I state the restrictions by just finding the restrictions of the denominator, and then I go ahead, put everything back together, and then simplify it. That's just the way that works for me, because I find myself getting very overwhelmed if I have to factor the top and the bottom and then I got all these things going on. It's just messy for me. So I actually do split that first step up into 2 steps. If you would like to do it all as 1 step, be my guest. I'm completely okay with that. Just saying that this is a method that works for me if you find yourself struggling to organize your thoughts on a math test. Okay, so let's do this. Let's go ahead and do step 1. And I'm just going to write a step 1. I'm going to say factor the numerator. And I'm doing numerator because it's low stakes. We're not really doing restrictions with the numerator. Okay, so let's go ahead. Let's do that. So we have x squared minus 5 minus 6. So here I need to find 2 numbers that when they add up, right, they're going to give me negative 5. And when we multiply them together, they're going to give me negative 6, right? So the only 2 numbers that I can think of right now are negative 6 and 1. If you add negative 6 and 1, it'll give you negative 5. If you multiply negative 6 and 1, it's going to give you negative 6. So negative 6, 1. So I'm going to just go ahead. This is a simple trinomial, and this is when I said, like, you can solve by decomposition. I'm going to use the other method that we learned, just a simple trinomial method, because I find it just saves me time, right? So I don't want to do decomposition right now. So I just went ahead and did that. But if you want to do decomposition, be my guest. This will just save you time on a test or a quiz, because now factoring is step 1, right? Instead of the entire equal question. So then what we're going to do is we're going to go ahead and factor the denominator. And I'm just going to write it as denom, because I can't be bothered to write denominator. So let's go ahead and factor the denominator. So our denominator, if we look at it, x squared is a perfect square, 36 is a perfect square, so this is the difference of squares, right? And there's a subtraction sign in the middle, so I'm just going to go ahead and say y to this. Difference of squares. So then what I'm going to do is I'm just going to take the square root of the first number. So I'm going to take x. I'm going to take the square root of the second number, minus 6. And then x plus 6. Right, and that'll give me my denominator. Again, you could have done this by decomposition. No harm, no foul. It's just, it's important to remember that sometimes it'll just take you longer that way. Okay? Step 3 now is going to be, let's go ahead and state the restrictions of the denominator. So let's go here. I'm just going to go look at just the denominator. So the denominator here, once it was factored, we found out it was x minus 6, x plus 6, right? So now let's split these 2 brackets up into things that we can actually solve. So let's do x minus 6 is equal to 0, cannot equal 0, and then x plus 6 cannot equal 0. Right, because both of those brackets can't equal 0, so this will become x cannot equal 6, x cannot equal minus 6. Right, you could also write this as x cannot equal plus minus 6. I have no problem with that, just writing it out for you though. Now we're going to go on to step 4, which is just going to be simplifying. And notice how this is step 4 and not step 3, and that's just because I did step 2 or step 1, whatever, as 2. So it's a little bit more work there. So let's go ahead. So our numerator, and this is where it's important to make sure you go back and you look at your numerator. Our numerator is plus 1 from step 1. Our denominator was x minus 6, x plus 6, right? Let's go cross out the things that aren't there anymore. X plus 1 over x plus 6, such that x cannot equal plus minus 6. So this is also my statement piece right here. I just didn't want to go ahead and do it anymore. So that's my answer. That's my statement with the restrictions. Okay? And I'm going to have you move on, and I'm going to have you try this one on your own. So pause the video, come back, and just watch me work through it after. I do like to post the video of me working through it, not just the solution, so that you can see the kind of steps that I'm taking, but I do want you to at least try this on your own once. Okay? All right. Okay, so hopefully you pause the video, come back, and we'll take this up together. So, same thing. I like to go through and I like to do, let's do the numerator first, then do the denominator, then we'll go back and we'll state the restrictions, then we'll go and simplify it, and then I will put a statement out, okay? So let's start off with the numerator first. So I'm just going to write numerators just so that I remember it for myself. You don't have to do that. I'm just doing it because it helps me kind of jog my memory when I'm looking back at this stuff. So I'm going to say 10x squared plus 25x minus 15. So right off the bat, I can see 10, 25, and 15. Those are all multiples of 5, so I know I can pull the 5 out. So I'm just going to pull the 5 out. Can't pull out an x or anything like that, so I'm just going to go ahead, divide 10 by 5, which is going to give me 2x squared. 25 divided by 5 is going to give me 5x squared. 15 divided by 5 is going to, or not squared, just 5x. And 15 divided by 5 is going to give me 3, right? Now I'm going to focus on what's just inside the bracket. I need to find two numbers that when you add them together will give me that middle term, which is 5. And when you multiply them together, now you need to remember, because this has a 2 in front of the x squared, it's a complex trinomial, right? So that means I need to find two numbers that multiply to give me negative 3 times 2, which is negative 6. Okay, so now I need to find two numbers when they multiply together, they give me positive 5, but when they multiply together, they give me negative 6, but they give me positive 5. So in the last one, we found two numbers that gave us negative 5 and negative 6. You just need to be careful of that. They're not the same numbers. In this situation, it's going to be negative 6 and positive 1. So those are going to be my two numbers. Again, I do need to go in and do this by decomposition. I can't do the simple method, and that's because the fact that they are both complex trinomials. So let's leave the 5 on the outside. Let's go and just deal with what's in the middle. So I'm going to say, okay, we have 2x. We're going to break up that middle term. So instead of 5x, it's going to be minus 6x plus x, or plus 1x. You can write 1x. I have no problem with that, right? Bracket. So let's go ahead and make our little other brackets around these numbers. So I'm going to do that, factor by grouping. Then I'm going to go in here. I'm going to leave the 5 on the outside so I don't forget about it. But I'm going to see, okay, from this 2x squared minus 6x, I know I can pull out a 2x. So I'm left with x minus 3. And sorry, this was oops, it should have been, I did the mistake that I said I wouldn't do. Should be negative 6. It should be positive 6 minus 1. Sorry. So it should be positive 6 minus 1. So this should actually be a positive. And then this should be a minus x. So that changes things here. So it goes from, you're going to pull out the 2x. You're still pulling out the 2x. This is just a positive now. So it's x minus 3, or plus 3. Right, now you have a negative 1 in front of here, so I'm just going to pull out the negative 1, and I'm left with x minus 3 as well, right? So then I'm left with 5. One bracket's going to be 2x minus 1, just the numbers in front, and then the numbers in the second bracket are there. So I'm left with 5, 2x minus 1, x plus 3. That is my numerator, my new numerator, my factored numerator. Right? And sometimes what I like to do is I actually like to go back to the original equation and just be like, okay, this equals 5, 2, x minus 1, x plus 3. just so that it's there for me and I remember that I did that already. So let's go ahead and factor our bottom one, right? Our bottom option was 2x squared plus 12x plus 18, right? So now what we're going to do is we're going to pull out the 2, right? Because you can divide 2 by x, you can divide 2 by 2, you can divide 12 by 2, and you can divide 18 by 2. So let's pull out the 2. So I'm going to say, okay, 2, then I'm left with x squared plus 6x plus 9. Notice how now I have a simple trinomial, so I just want to find two numbers that when you add together, right, and I'll write this out. So I'm going to have m plus n, that when I add them together, they're going to give me 6. But when I multiply to them together, they're going to give me 9. And really the only two numbers I can think of right now are going to be 3 and 3. Another thing you could notice is that this is actually a this is a PST, which is a perfect square trinomial. Again, for me, I personally just looked at this and I found it easier to do it by decomposition. But if you could see this and be like, oh, it's a perfect square trinomial, pretty easy to remember that it's a perfect square trinomial. So you can just go ahead and write out x plus 3 squared. But I found it easier to just do it this way. So I said, okay, so one bracket's going to be x plus 3. The other bracket's going to be x plus 3 because those are my two m&ms, right? M and n. So 3 times 3 gives us 9, plus 3 gives us 6. So then I know that x plus 3 and x plus 3 are the same bracket, so it's just saying x plus 3 squared. And that's going to be my bottom. For now, for the purposes of this particular lesson, I'm going to leave it as the two brackets. And that is with good reason. And I'll show you why. Okay. So now what I'm going to do is I'm going to look at my denominator and I'm going to state the restrictions. So let's figure out what x cannot be. So x plus 3 cannot equal 0. Cannot equal 0. So x cannot equal negative 3. You don't have to do it twice. It's going to give you the same number, just so that you know. You don't have to go ahead and do that. Then what we can do is go ahead and look at number 4. So let's start to simplify this polynomial out. So I'm actually just going to take this, and that's why I made it up there. I'm going to put it over here and go ahead and simplify it out. Right? I just took my numerator and my denominator and put them together. So now I want to simplify it out. Let's cross out these two because these two have the same number. So what I'm left with is 5. 2x minus 1 divided by 2x plus 3. And since I want to make my statement piece, I'm just going to go ahead and write here, x cannot equal negative 3 because that's my restriction. And this is my final statement. Does that make sense? It's a little bit more work. A little bit more complicated, but that's fine because it's going to, that's the point, it's that it gets complicated as we go on, right? So I want you to have worked through the next one by yourself, and then we will take it up together. So please do pause the video, go through this one by yourself, and we can take it up together as a class, okay? I will just post the solutions for this one on D2L. I want you to actually go through and work on it on your own. If you have questions about the solutions, of course, message me. We will work through it together. But for this one, I actually want you to try it on your own, and then I will come back here and I will, after this lesson, I'll have us walk through the solution if you need the help. If not, I will just post the solution on D2L as well. Thank you. I'll see you all tomorrow.